Hi everyone, in this second video tutorial about 4-point bending test of reinforced concrete beam using Abaqus, we will add strengthening composite material to our beam for decrease our strength of our beam. We use composite material as lamina type, and also we do all necessary steps to combine and successfully our job. We also analyze the result between and compare the result between two models with and without composite material. Let's get started. First, we have our assembly of our 4-point bending test of concrete reinforced concrete beam. We have ruler when we apply our load and support and our concrete beam, reinforced concrete beam, and we can see our rebar and reinforcement of our. We can see inside our reinforcement steel. Now let's go to create our composite material, create part, composite, 3D deformable solid extrusion, click continue and create our part by sketching, create rectangular, add dimension 1500 millimeter in the length of our sheet of composite, and we have 150 millimeter in the width of our sheet. We have our sheet of composite, click done, and now we need to add thicknesses of our sheet, click OK. Now we have our composite part for reinforcing our concrete beam. Now let's create our composite material. Mechanical elasticity, elastic. Go to type of material. Let's select lamina type. Let's go to Young modulus in the reference direction. Units of our parameters is in megapascal and millimeter. Now we have all data in our property of lamina type composite. Click OK. Now we need to assign composite material and add different layers in our sheet of composite. Let's go to create composite layer, add a name for our layer, and add how many layers you need to add in our sheet. Let's add, for example, 10 layer. Now we can select element type. In our part we have solid part in 3D. We need to add continuum shell. Select continuum shell, click continue, and now select first, select region of our layer, composite, material we need of each layer, composite, relative thicknesses. Let's add 0.2 for each layer, click OK, and rotation angle is 0 degree, or we can change for each layer at you can add thick angle for each layer. Let's edit orientation. You can edit 45 degrees in online. Let's edit 0 degrees. Okay, as you can see here, we have the reference direction is the x direction. This direction have the Young modulus E1 and the second direction E2. We can change this stacking, but it's okay for our model. Click OK. Now let's go to assembly part, and we need to add our sheet composite to our model. Select apply. Okay. First, we need to rotate this part in the right position. Select part. Select axis of rotation. Select starting point of axis of rotation and ending point for axis of rotation. Angle of rotation 900 degree. Click OK. Now let's move this part to the right position under concrete beam. Translate instance, select instance, and select this point, move to this point in the concrete beam. Now it's in the right position. Click OK. We have the right position of our sheet. Click done. Now let's go to interaction module and create tie interaction between composite material and our concrete beam. Let's create tie, select surface, let's replace part, select our composite, replace, select the top surface of our composite part, and now select the bottom surface of our beam concrete. Let's select our bottom surface in the interaction and in the contact with our composite. Click done. We select the main surface is the surface in the top of a composite part, the main surface, and the secondary surface is the bottom surface of our beam. We can switch between these two surfaces, but it's okay, this configuration. Click OK. Now let's go to load mesh, and we need to meshing our part, composite part, 10 millimeter or 20 millimeter. The size of elements, mesh, yes. Let's go to job module and create our job. Create. Strengthening concrete beam. Click continue. Okay, let's check our model. Submit. We have aborted situation. Let's go to monitor. We have 600 elements have missing property definition. Error element missing section. Let's go to mesh. Let's see which element have this problem. Go to result and go to selection display part, select or element. We have error element missing section and headlight item in our viewport. Click and the composite material appear in our for this error. Let's go to mesh module, part and edit, mesh control. We have 3D stress, but in our analysis you need to use continuum shell because we select continuum shell previously in our selecting for material for assign material in our part composite. Let's click OK. Go to job, data check again, click OK. Aborted also. Let's go to monitor. Now we have another errors. The local wind direction after special normal orientation local. Let's see the position of this problem, in which part we have this error. Let's go to part, element orientation. Headlight in items in viewport is the same position in composite material. Let's go to mesh. Now go to assign stack directions. Let's click on it. Select top face reference orientation. Let's select top face. Click yes. Now we have right orientation of our stacking. Let's go to job again, submit. Okay. Continue. Okay. Data check. Completed check without any errors, any previous errors. Now let's continue our process. Click OK. Now we have aborted. Go to monitor. Analysis exists with an error warnings, but we have a result. Let's go to result and let's remove edges. Apply OK. Let's feature edges. Apply OK. Now we have misses, stresses. Let's see our stresses in the composite strengthening. And now let's go to damage in our concrete damage in compression. We don't have any damage in our concrete. We don't have any compressive damage, but we have tensile damage. Let's compare the result with simulation without composite. Let's compare with model without composite. Create new viewport. And now in this viewport, click on it, and let's open. Let's go to top and select ODB, beam ODB result. Now let's select and let's link to viewport, and let's see damage. Now this is the result between two parted, two model. The first one is without strengthening with composite, and the second one was strengthening with composite material. Let's go to stresses, plot contour, and we have we we decrease the stresses and also decrease the tension damage and compression. In this model we have damage in compression, but in this model we don't have damage in compression. Let's go to tension, and we have a better result in this model compared with this model. Until now, I hope you enjoy with this video tutorial. Don't forget to subscribe in my YouTube channel and like this video. See you in the next video.